Mark my words, you harness that negative power of yours and you can make it to the top, just like me.
Oh, thank you.
I'm not just over one, I'm over everyone. We continue studying the rules of exponents, and today we will study a negative exponent. But before that, let's review the rules of exponents. So we did the multiplication rule, we just add the exponent. The division rule, we just subtract the exponents, be sure the bases are the same. And then the power rule, exponent with an exponent, just multiply them. If there's a bigger term inside, distribute that x, multiply it to each of the exponents inside. And there is also the division rule. This is distributed to A, and this is also distributed to B. We also studied the zero exponent. Anything to the zero power is 1. And today we will study the negative exponent. This looks weird, but we will shed some light about the meaning of a negative exponent. Now, this guy is surprised. How can a base have an exponent of negative 2? Does that make sense? Is it 5 times 5, but it's negative 5? It's confusing. Alright, don't worry. Is this possible? Yes. Check this out. 5 to the 4th divided by 5 to the 6th. Let's do expanded notation first. I expand 5 to the 4th as 5 times 5 times 5 times 5. 5 to the 6th, I write it 6 times, then multiply them. Next, we can cancel out because the value is 1. The value of 1, the value of 1, the value of 1. So the remaining number would be what? This will be a 1. It's not a 0 because 1 times 1 times 1 times 1 is 1. And the remaining exponent at the bottom will be 5 to the 2nd power. So you could say that 5 to the 4th over 5 to the 6th is equal to 1 over 5 to the 2nd. Remember that. Now, let's apply our division rule. What did we learn before? We learned that 5 to the 4th over 5 to the 6th, there's a shortcut, simply subtract the exponent. So let's do that. So that becomes 4 minus 6 is a negative 2. Okay? So take note, if I divide these two, I'll get 5 to the negative 2. That was our previous answer in expanded notation. This is our answer using the division rule. So meaning these two are the same. That negative 2 becomes like this, the same. We can now say that 5 to the negative 2 is the same as 1 over 5 to the 2nd. We've proven that a while ago. Think of a shortcut. If you see a negative exponent, how did I transform it into a fraction? What's the meaning of it? See that? Okay. So one more example. A to the 2nd power over a to the 7th. I expand. Cancellation. That's a 1. That's a 1. The answer here will be 1 over a to the 5th power. Now let's apply the division rule. A to the 2nd over a to the 7th. 2 minus 7 is a negative 5. Again, just like a while ago. Whenever I see a negative exponent, it's the same as that one. They are the same. So I think we can make a generalization now. A to the negative 5th is equal to 1 over a to the 5th. So every time you see a negative exponent, it actually means this way. There are more 8's below. Think of a shortcut. Let us make a rule with negative exponent. Every time you see a base with a negative exponent, think of it this way. It becomes a fraction. A fraction. And what number is on top? Yes, the number is 1 because there's nothing left on top. But at the bottom, there are more bases. There are more numbers to be multiplied. And how many times is that? The same as a negative exponent. Simply put this under, and then that negative disappears, and then the 1 is on top. For example, 6 to the negative 4th, what is on top? Yes, numerator is a 1, and the denominator is 6 to the 4th. Okay, you got it? Eliminate the negative exponents. I'll give you 3 questions here. Try it out first before I give you the answers. Ready? Okay. First one is 1 over 5 to the 4th. Correct. This becomes 1 over 12 to the 7th. Correct. This becomes 1 over 8 to the 9th. You got it. Good job. More. Try this on your own. Ready? Here we go. That becomes 1 over 6 to the 5th. Both of them are negatives, therefore, and your answer is 1 over 12 to the 7th, b to the 2nd. Correct. For the last one, only this has a negative. So the answer will be what? A to the 3rd is still up there. It won't go down because it's not negative. So a to the 9th means there are more 8's belows to be multiplied. Correct. Try this on your own. Here's the answer. C to the 3rd stays on top because it's positive. Only this will go down the denominator. Correct. That's it.